So yesterday we started with 2-1, and today we're going to keep going with 2-1. It's more rational coefficients. So we're going to write this stuff down. So rational coefficients is kind of what we're looking at today. All right. Rational. What does rational mean? Who knows? Raise your hand. What's it mean, Andres? Something that can turn into a fraction. That's really good. You're really smart. Looks like ratio, right? Okay, so they're decimals and fractions. That's what we're doing today. We're still doing one-step equations, but instead of whole numbers like we did yesterday, we're doing decimals and fractions. So here's an example. We have 3/4 C equals 18. 3/4 C equals 18. That's a fraction. Anyone love fractions in here? No, like nobody, right? You do? No. All right, we're going to work this out. In order to solve for C, I have to get rid of 3/4. Do you guys think I add, subtract, multiply, or divide? Add, subtract, multiply, or divide. Raise your hand for add. Raise your hand for subtract. Raise your hand for multiply. Raise your hand for divide. If you said divide, you're right, but really what you're going to do is divide and multiply. So here's how you do this. Remember that multiplicative inverse thing? We have to use that. So we multiply by the reciprocal. And then we can cancel some numbers out, right? So if I multiply by the reciprocal, that's 4/3. So whatever I do on one side, I have to do to the other side. 4/3 times 3/4, that's going to equal what? 1. Remember? And then we can say, oh, 3 goes into 18 6 times. So I can simplify before I multiply. I know in 6th grade you did a lot of this cross-canceling kind of stuff. Simplifying before you multiply your fractions. So we should get 6 times 4 here, which is 24. What should we do next? Are we finished?
Yes.
How do we get 100%? Plug it back in. Good. So step 2 would be to check your answer. Plug 24 back in for C. And yes, 3/4 times 24 equals 18. Check. Questions?
How did you get 6?
Good question. 3 goes into 18 6 times. 6 times 4 is 24. All right. So I want you guys to practice 4 of these. Practice these 4. A, B, C, and D. Okay? Yeah, practice it right into your notes. No, we're not done. There's one more page. But they're easy, yeah. Do those, write them down and see if you can get them right, and then I'll give you the answers in just a couple minutes. of these you could probably do without writing anything down. Like the first one. You probably know that. So let's see what you got. So A, who wants to give the answer to A? Bryce. 60. Raise your hand if you got x equals 60. Good. That's just 5 times 12, right? All right. Part B. Who wants to do B? Connor.
I got D equals negative 18.
Good. Negative 18. Raise your hand if you got negative 18. So all you did was you flipped them over, multiplied. You could cross simplify. Don't forget the negative. And part C, who wants to do that one? Anyone for C? Nobody? Alex.
9.
It is 9. Raise your hand if you got 9. Good. So what did you have to multiply to get 9 there?
15 times 3 to 15.
So did you change the 15 to 1 over 15? Or sorry, did you change the 5/3 to 3/5? Good. So sometimes when we move these around, like see right here the variables on the left, and now the variables on the right, people get confused and they start moving this over there. They start doing that. And then I'll see them write, oh, let's write 1 over 15 over here. So be careful. That's one of the most common mistakes I see on the test is they're used to like moving things from the left to the right, but it goes both ways. Okay? And then part D. Anyone get that one? Anybody else? Pam? It's not negative because there's 2 negatives here. So it's 28. Positive 28. Raise your hand if you got positive 28. Good. Okay, so we're multiplying this one by negative 7 over 6. Yes?
How did you do B?
B is, you just multiply this 4 by negative 9 over 2.
Like, how do you do that? Like, you put a 1 under the 4?
Yeah, let me show you. So you just go like this. You actually don't need to put a 1 under the 4. Let me find a pencil that works here. Hold on. You can if it's easier for you to visualize that way.
Divide.
But you don't have to. So you could just say, oh, this is 4 times negative 9 halves. And then 2 goes into 4 twice. And then 2 times negative 9 equals negative 18. If you want to put a 4 under there, it's fine, but you don't need it. Okay? We'll keep practicing. Okay, any questions on this page? That was it? Easy? Yeah, Jared?
How did you do D? Because 7 doesn't go evenly into 24.
Yeah, but you're flipping it, so 6 goes into 24.
Oh.
No, it's not stupid. It's a good question. Yeah, Connor.
There doesn't be any like where it doesn't go into the, and it's going to be like a decimal.
Yeah. Okay, let's look at the next page notes. Okay, example 2 has some mixed fractions. You guys remember how to rewrite mixed fractions? Let's see if you remember. So this is 1½ s equals 16½ So we have to rewrite them. So remember we go 2 times 1 plus 1 is 3, and you keep the denominator. Remember this from elementary school? And then this is 2 times 16 is 32 plus 1 is 33 over 2. Any questions on that, rewriting the mixed fractions? Raise your hand if you remember that. Good. Some of you are still looking like, what's going on here? Okay. So after we rewrite them, then we just divide by 3/2, which means we multiply by the reciprocal. So we're going to multiply everything by 2 over 3. 2 over 3. This side is going to cancel out, make 1, right? This side here was nice because I could get rid of the 2's. And then 3 goes into 33 11 times. So s equals 11. Okay, so step 1 is rewriting the mixed fractions into improper fractions. And then we just solve it like normal. And then are we finished? What should we do next? Plug it in. You knew that was coming, didn't you? So just when you plug it in, go to the improper fraction. If you plug it in up here, you're going to be hating yourself because then you have to multiply mixed fractions. So don't do that. Plug it into this. So 3/2 times 11 is 33 over 2. Okay? And that's what we should get, 33 over 2, right? So yes, it works. Okay, yeah.
I'm kind of confused because what if you like flip the 33 to over the 86 and then be 33?
No, you only flip the one side. So we had 3/2 and we make it 2/3. Okay? All right, so let's practice a few to see, because yes, it is confusing when you're dealing with these mixed fractions. So I want you to do, let's see, there's 3 of them. And I'll give you a few minutes to get through those. Just do them right in your notebook so you have examples. For each one of these, you will get an improper fraction as your answer. And you can change it back to a mixed fraction if you remember how to go back and forth. If not, I will show you. But you should get it improper, and then just see if you can figure out how to change it back, if you remember. Get these right. I know these are not as simple. And some of your brains hurt, yes? Yeah. Okay. All right, so anyone think they know number, or part A? Anyone want to go for that one? Lucas, thanks for volunteering. What did you get for A?
I didn't get that one.
Didn't get that one? Were you close? No? Paige? No? Imani? What'd you get? One and what? You just got one. Anyone get a different answer than one? What'd you get? 1 1/4. Anyone else get 1 1/4? Okay, 1 1/4 is correct. Not very many of you got it. So let's see what's going on here. So we look at this and we go, okay, 6 times 4 is, plus 1 is, so right, 25 over 6 equals 3 times 3 is 9 plus 1 is, so we write 10 over 3 C. Now we have to multiply both sides by what? 3 over 10, right? The reciprocal. All right, so now that gets rid of these ones. And I'm looking here and I'm thinking, I don't really want to multiply and then divide. I would like to simplify this first, right? So 3 goes into 6 2 times. What goes into 10 and 25? 5, right? So 5 goes in that one twice. 5 goes in that one 5 times. So now what is, oh, I only have 5 on the top, right? So this is 5 over 4, right? 2 times 2. C equals 5 over 4. And you could change that to 1 and 1/4. So or. How do we change it to 1 and 1/4? How do you do that? Alex, how do you do that? Yeah, how do you go from an improper to a mixed? So you divide 4 into 5. And how many times does 4 go into 5? 1 time. And what's left over? Remember remainders? Remember those? Yeah. So we say, oh, it goes in 1 time and we have 1 out of 4 left over. Do you remember this? Vaguely? This was a long time ago. All right, let's see. Did anyone get B? Any answers for B? Did anybody get something like negative 11 and 17 over 77? Any big numbers like that? Anyone get anything with 77 in it? You did? What'd you get? Did you get that, what I said? Okay, let's do that one. This one's ugly, right? So what's 8 times negative 9? Negative 72 plus 5. So do we leave it at negative 77? Or do we do negative, what is that? 67. Does anyone know what happens when you do the negative? You forgot, huh? So you were supposed to see some of this in 6th grade and a little in 7th. But here's what you do. 8 times 9 is negative 72. And you keep the 5 negative. So this is going to be negative 77 over 8. Do you guys remember that rule? You keep it negative? Who remembers that? Probably like one person, right? Because we rarely do this kind of problem. But you keep it negative. And then this equals 108. And then we have to multiply each side by the negative 8 over 77. Negative 8 over 77. And I don't think this one actually simplified, which is why it was so ugly. So you actually had to figure out 108 times negative 8 divided by 77. So the answer here worked out to be a negative 11 and 17 77ths. Isn't that ugly? Yeah. Do you think that I should put that one on a test? No, I don't think so either. What about part C? Did anyone get that though? That one wasn't too bad. What'd you get?
I didn't simplify, but I got 135 over 16.
Okay, so it can be simplified. Did anyone get it simplified? You did? What'd you get?
I got y equals 2 over 2/5.
Yeah, 2 and 2/5. So this one is actually 2 and 2/5, or you could have had 12 over 5. Anybody get those? Good. All right. One last thing, simple thing. The simplest we'll do. The decimals. Those were fractions. Decimals are way easier, right? So we can just punch them in our calculators. So here's an example. We have 3.15 equals 0.45 n. 3.15 equals 0.45 n. How do we solve for n? You guys know? Divide by what? .45. I see some of you saying it. So we divide by 0.45. And when you put that in your calculator, you get 7. Works out. Yeah. Can't see it, huh? Sorry, guys. Better? Okay. So that's a real simple problem, right? Way better than fractions? Yeah. We check our answer, plug the 7 back in, and yes, it works. So the last thing you guys are going to do in your notes is I have, I think a couple examples, maybe even one. Let me peek. 2 examples with decimals. Okay, you may use a calculator. If you have your calculators, it's fine. You can go borrow one of mine if you want. Did you guys get this page? The last part is just checking the answer. Okay. So the last page is 2 practice problems with decimals. And after you finish that, you can write down this where it says quick review on percents and decimals, because we need to know how to fix our percentages and make them decimals. And this is 7th grade math, and you probably forgot it by now, huh? Maybe 5 of you remember. So get these 2 answers and then write this stuff down, and I'll give you about 3 minutes, and then we'll go over it. Okay, so for part A, T equals what? You guys can say it. What'd you get? T equals 7. Raise your hand if you got 7. Pretty good. And part B, K equals 2.3. Raise your hand if you got 2.3. Good. Anyone accidentally put negative 2.3? Sometimes you forget, right? So be careful on those negatives, positives, because those are easy points that you miss on the test and homework and stuff. And then quick review of percents and decimals. To write a percent as a decimal, you have to move the decimal 2 places to the left. Do you remember this?
Yeah.
So like 3% is 0.03, 75% is 0.75, 110 is 1.1. This will come up in word problems where it'll say something like 75% of football players get concussions. Totally unrealistic, right? Okay. It'll say something like that. How many of this is that? And you have to figure out, oh, I need to use a decimal to do this. Okay, or maybe it'll say 90% of students hate fractions.
Yeah.
Oh, that's more realistic. And then it'll say 99% of students hate mixed fractions. And then it'll say 110% of students hate mixed fractions and decimals. Right? Something horrible. Some horrible word problem where you have to convert your your percentages into decimals. All right, any questions?